Okay, we are live. Let's get started. Hi, everyone. Welcome to today's webinar titled Optimizing Solar Data Management with Time Series Database. My name is Jim, and I'm the co-presenter and host for today's session. Joining with me is my good friend, Patrick. Patrick is the principal software engineer from Nevados, a major manufacturer for all-terrain solar trackers. Patrick, do you want to tell a little bit about yourself?
Yeah, hello, welcome everyone. My name is Patrick. I've been in software for about 25 years now. I grew up in Germany, studied in Germany, and then started traveling the world. Now I'm based in Colorado. I specialize in JavaScript applications. That has been my primary passion for the past 15 years, focusing on Node.js and all sorts of front-end technologies. I do a lot of community work. I started in Barcelona with Barcelona.js, co-founded that, and moved along, and currently I'm co-organizing Boulder.js, and I'm very passionate about emerging technologies, everything that's new and upcoming, and yeah, hoping to shape for a greener world and for a better, more sustainable world.
Awesome. And we can tell from your picture that you like hiking a lot too, right?
Yes, I'm a big outdoor fan.
Awesome. So to go along with your picture, I actually changed my profile picture because I like fishing a lot. I'm also an outdoorsman. So a little bit about myself. My academic background is in engineering. So I graduated from University of Michigan about 13 years ago. I've been working in the manufacturing and industrial IoT spaces since then. And I also worked in areas like smart manufacturing, autonomous driving, and renewable energy. In my spare time, I'm a big time fisherman. This is the fish that I caught in Michigan when I was living there. Right now, I'm based in the San Francisco Bay Area. All right, let's take a look at the agenda for today's presentation. So I'm going to start off by introducing a little bit about the industry challenges, why we are talking about this topic today. And then I will dive a little bit into the time series database in general and talk a bit about TDengine. Then Patrick is going to take over and introduce Nevados, why they chose TDengine for their operational data management, and some of their existing deployment and applications with TDengine. At the end of today's session, there will be a Q&A session. So if you have any questions regarding today's presentation, or the product that you see in the slides, please feel free to ask questions in the chat window. We'll try to get them either answered at the end of today's webinar or following the webinar. Okay, a little bit on the renewable energy side. So why are we focusing on the renewable energy? Why do we pick that as the main topic to discuss today? And as we all know, there are two big trends happening in the renewable energy sector. One is, of course, the rapid growth in the renewable energy production. According to a report by International Energy Agency, the renewable energy production is going to double in 2028, more than double in 2028 compared to 2022. So we all know that we're living in an era where there's a huge rapid growth of renewable energy, whether it's wind, solar, or any kinds of renewable power generation form. A second trend is the digitalization or digital transformation. So with the increasing number of smart sensors and IoT devices being deployed on those renewable sites, we're actually getting more and more operational data and also more and more operational insights into what we're doing. And that also means that combining the two trends, on the one side, we have more and more solar sites and wind farms. And on the other side, there's more devices being implemented in those sites. And that can result in an ever increasing amount of operational data. And most of these operational data do exist in the form of a time series. And that leads to our next slide. So what is time series databases? Or let's start with what is time series data? A time series data is essentially a data that with a timestamp. In the manufacturing, for example, you can record a lot of the manufacturing process data with a timestamp. So these are time series data, but also, let's say if you want to do predicted maintenance on certain machinery, you would often need to install what so-called a vibrational sensor or accelerometer on certain machines. And these sensors give out, these sensors very high sampling frequency. So they would generate anywhere from a few thousand data points to like 50,000 data points per second. And these are all time series data. So we're dealing with a huge amount of time series data in these applications, for example. And in other industries, for example, in the autonomous driving or self-driving vehicles, if you have a test fleet of a few thousand vehicles, you also get a ton of telemetry data when you are actually driving these vehicles, right? You want to get the vehicle speed, acceleration in different directions, things like that. And in the finance industry, level 2, level 3 stock market data, it's also, there's a ton of time series stamped data. So this is just a data that's commonly being used by people from various industries at this point. So what do people use these data for? Let's use renewable energy as an example. For example, on a solar farm, we would usually get the data to measure the energy production efficiency, for example, on the solar farm or for the solar panels. And if you see a gradual decrease in the power generation efficiency from your data or from your monitoring dashboard, it means something is wrong. Probably it's being covered by dust. Maybe you need to send the maintenance team to clean the dust off your solar panels. And what's more interesting is that now with the advancement of big data, you will be able to tell from your operational data, like what's really going on with your solar panels. Is it covered by dust or is it covered by snow? And the data pattern for a solar panel being covered by vegetation is really sometimes very different than the data pattern, for example, that you observe from a solar panel being covered by dust. So you can do a lot of, not only get those data, but also gain a lot of insights into those data using the modern technology, using the big data, without ever sending anyone there to observe what's happening. So with the time series data, you can do a lot of monitoring, real-time monitoring. You can predict future trends. You can detect anomalies, and that all really provides you with a lot of insights into your operation. So why do we need a specialized database management tool for time series data? Can we just use a traditional generic or general database to manage the time series data? I would say, like, when your data size is small, of course you can almost use any database that you want. But as your data size increases, as you scale your business, sooner or later you're going to run into some kind of a data pipeline issue. And with the time series database, one of the major benefits is that usually it employs or it deploys some kind of a time series specialized compression algorithm just for time series data, which means you can compress your data up to, with a compression ratio up to 10:1, for example. Your original data type is 10 terabytes. You can compress that data to 1 terabyte or even less. That means a couple of things. First, it will drastically reduce your data storage costs. And secondly, it means that you will also increase your data ingestion rates. In the time series database like TDengine, we can easily ingest up to 2 million data points per second or more for our users. And on the query side, if the time series application often needs a scan of a huge amount of data points to generate some kind of a result. If you're using a generic software, a generic database software, it can usually result in high latency. But with the time series data like TDengine, in certain applications, we can do data aggregation, we can do query over 10 billion rows of data under just 1 second. So it's really high performance, lower cost. If you're dealing with operational data or time series data, it is almost a no-brainer at this point to use a dedicated time series database. A little bit about TDengine. So we were founded in 2017. We're an open source database software company, And with our open source version, there are over 600,000 downloaders already across 50 countries worldwide. So there are a lot of people using TDengine every day throughout the world. And we also have over 200 paid customers in various industries. Most of them are concentrated in the energy, utilities, manufacturing, and automobiles. And we have offices in North America and Asia with over 100 employees right now, and of which more than 60% are developers. So we have more than 60 developers at this point to improve TDengine in a very rapid pace, along with our huge number of actual users. They all contribute to the improvement and development of our core base, our core code. And with TDengine, we have we're an advocate for open systems. So we don't want to be a closed system, which means we want to be compatible with as many technologies out there as possible. So TDengine itself, it's really a time series database for industrial IoT, and we run on all the major cloud platforms like AWS, Azure, GCP, or on-premise. So you can get data from various sources using different industrial protocols like MQTT, OPC. You can also get data directly from some of the data historians like the Pi system or Wonderware. And when the data is in TDengine, you can connect with any major or mainstream analytical tool or visualization tools like Grafana, Seek, Power BI, Tableau, or any other machine learning AI tools that you can think of, because we support JDBC and ODBC connectors. And when you have your data in TDengine, it's also super easy to share your data with your suppliers, with your partners through data subscription. You can share the entire database. You can also share maybe just a column or a portion of the database as you want, as you wish. So we say that compared to a non-time series database, really a time series database has a huge advantage in the performance and also in the cost. But how about like within time series database? So these are the reports that's done by what's so-called a TSBS, and that is an industry standard benchmarking tool. So it's not invented by TDengine, it's an industry standard benchmarking tool designed to measure and compare the performance of different time series databases. And we used that standard tool to did some comparison between TDengine and some of the other major time series databases on the market. And on the query side, this is, I believe, the average response time for 5,000 queries. So if you perform 5,000 queries, what is the average response time? And the blue color here is the TDengine, and the orange and red colors are from two other major time series databases on the market. As you can see, our query time can be 30, sometimes up to 30 times faster than other tools, other solutions on the market. And on the data ingestion side, we're also up to 10 times faster than some of the other solutions. And not only do we have higher performance, we also consume less resources. And this, as you can see on the left-hand side, is the disk space usage. On the compression side, we have an even better compression results compared to the other tools on the market. And on the CPU usage, on the right-hand side, you can see that the blue color represents TDengine. As you start the instance, the computing resources that we occupy or the CPU usage that we apply is definitely much lower than some of the other tools on the market. So with the TDengine, within the time series database, TDengine is a high performance tool with very low computing resources cost. And the next two slides before I pass over to Patrick is some of the case studies we have in the solar space. So we work with a lot of solar and wind operators and also equipment manufacturers. So really anyone who has a lot of operational data to manage, we work with all different various types of companies in this space. And these are just two of the larger customers that we have. We think all the companies of all sizes can benefit from using TDengine as long as they manage and they ingest a lot of time series data or operational data. in this case, for example, this is one major solar operator. In total, they have about 10 gigawatts of solar power generation, and they ingest about 1 million data points. They have about 1 million data points, and their sampling rate is that they would generate the data for every 2 seconds. And so before using TDengine, they were using MySQL, but soon they were running into data pipeline issue, and that's why they switched to TDengine. And another example is an even larger operator. They have 40 gigawatts of power generation in total. They connect 300 wind solar storage sites across different countries. And what they are doing is that they're now building a data center to centralize all these data and do analytics based on that. And their data they have a pretty huge data size. They ingest about 800 terabytes to 1 petabyte data per year. And once the data is in TDengine, they would do a lot of applications based on that. They would create dashboards. They would do AI machine learning study to improve their operational algorithms. They would also create a lot of BI report or insights into their operation to improve their operations with that. So these are just the two of the larger customers we have. But again, like customers of all sizes have been using TDengine, have been benefiting from TDengine. So that will be the end of my session. Now I'm going to pass it over to my friend, Patrick.
Thank you, Jim. All right. So at Nevados, we've been using TDengine for about 2 years now. The objective of Nevados is to provide cost-effective solar tracking solutions. So we're not so much about the power generation, more about the tracking and optimizing efficiency of solar generation. And to do that without grading. So we try to avoid grading, try to avoid ruining the environment. There's a lot of risk and cost associated with grading. So there's obviously a lot of flooding issues on graded solar sites, and they're running into more and more issues. There's obviously a lot more sand and dust built up when the site is graded. So we try to leave the site in its natural condition as it was before, and minimize all these grading work. There's a lot of regulation issues and permitting issues at the moment, because the government and the states realized there is flooding issues, etc. So a lot of sites are struggling with getting their sites graded, and that is where Nevados comes in. So the Nevados all-terrain tracker does 26% at every pile. So we can do very uneven terrain. What is time series data? Essentially everything that's coming in during the day that has a timestamp. As Jim already mentioned, there's a lot of it because obviously depending on the number of devices and the number of the frequency you're sending the data, the resolution you want it, if you want every second or real time or just every 5 minutes, this is all time series data. And I think one of the really interesting things about time series data is also that the older the data gets, the less important it gets. So if you're a month in, or like for most monitoring dashboard operation stuff, you would want real-time data. You would want to see what's going on right now. But then obviously for the past month, you want aggregated data. You want to see like the total health of the system. You want to see what has been going on. And then if you go further back for 6 months, 12 months, etc., the resolution of the data gets much bigger. And it's not important like what happened exactly at 11:20 at 16 seconds on September 19, but it happened like what happened that day or what happened that week or that month, the longer you go into the past. So that's where the compression stuff is coming in. And I find that really fascinating, how you're looking at data over time and how the importance reduces over time. I've been working in this field for a very long time. I haven't had encountered time series problems before, so to say. Like all the stuff that I worked before, all the fields I worked in was primarily always relational data or NoSQL data. So I went through a lot of different databases from MySQL, Oracle, Postgres, etc., through the NoSQL time when we had Couchbase and Elasticsearch and all these other cool database solutions. But in all this time, I never really had to deal with time series data, besides obviously the cloud logging and monitoring. But you would look for a log file, for example, for if something is going wrong and then forget about it or discard it when it's resolved. You don't really look for specific data and value in that data. So at Nevados, we encountered that issue, and we picked TDengine 2 years ago and started to build our dashboard, an operations and monitoring dashboard on top of that. So what you see here is one of our important KPI metrics, tracker on target. That's a calculation that aggregates the data and shows you in real time how many trackers are on the right schedule, on the right angle during the time. Just going back, a tracker essentially is a solar system that aligns your panels with the sun to maximize efficiency. You get about 20 to 30% more efficiency out of a panel if it follows the sun. And you can do some really cool stuff with stowing, for example, the panels. So when you see there's a hurricane coming in, you can stow the panels in a side stow, wind stow, to reduce damage to your solar panels, which is very important. So especially hail is super dangerous for solar panels. So when we know there's hail coming in, we stow our trackers and reduce the damage to almost zero. And also for hurricanes, we had case studies where our site wasn't impacted at all by a hurricane that moved over it, whereas a neighboring site was 30% destroyed or something with static modules. So there's a lot of stuff we can do, and obviously there's a lot of real-time stuff we need to do. There's some predictive stuff we need to do, weather changes. We operate weather sensors on site. We use weather data, and essentially we bring all that data together into the engine and then try to make sense out of it, what's happening. We don't have that much data yet, although I would definitely consider this kind of the big data. We do 1,500 inserts every 5 minutes at the moment. Every insert has 30 megabytes of data, more or less. So we cluster the data before and then send it over MQTT into TDengine. There are about 100 values or more per insert, and per month we're generating about 3 gigabytes per data, growing every month at the moment. So on the output, we do, on the busy times, we do over 1,000 queries in a 5-minute interval for zone trackers, data, real-time data, people that are visiting the dashboard and getting all these reports. And our aim on the API, where we collect and aggregate all the data, is to keep everything under 300 milliseconds, which is obviously a big challenge. But that's kind of the standard for responsive UIs and everything. So we have a lot of graphs. We have a lot of reporting tools. We have sorting, filtering, and everything that you can do. In terms of data architecture, we have the solar side. Everything is operating there in internal networks and everything. And then we send everything by MQTT through a broker. There are different ways with TDengine how you can do that. You can do a subscriber on the TDengine cloud, for example. They run an agent where you can just say, okay, this is my topic. Please subscribe and fetch all the data, which is pretty cool. We're in the process of migrating to a different broker that has the ability to send data. And then you can also do, on both sides, whatever way you choose, you can do transformations of the data, which I find very important for legacy data, for example. If you're operating all these sites, you can't keep them all on the same firmware, on everything up to date. There's a lot of regulation stuff. So if you're upgrading your data structure, or if you're sending new data through MQTT, we have to make sure that we're still receiving everything as before, and do proper migrations of the data on the MQTT level before we put it in the database. I'm going to show you a little bit of code. That's our TDengine wrapper in Node.js to get data out of, just to essentially process the queries primarily. So all the data that is, all the ingest is done before that. And then our API uses essentially this wrapper to process all the queries. We prototype our queries in Grafana. So we use Grafana internally, connected directly to TDengine to look at the data, see what's going on, try to make sense of the data, see what's important to our users, and test these queries, test the visualizations, see how it makes the most sense to our users, and eventually promote them into production. So we take the query, move it over into our API, wrap it in GraphQL or a REST endpoint, depending, and send it out to our UIs and implement the graphs on our UIs.
I think you missed one slide, Patrick. That is, yes.
Oh, yes. Sorry, I did.
The important slide.
The important slide, yes. Why did we pick TDengine? When we looked at this, again, that was 2 years ago, TDengine was one of the few database providers that had standard SQL functions. That was very important to us because the team that we're working with, they all know SQL. Everyone who has an IT background or developer background, everyone knows SQL to some extent. So that was very important to us to get into it as quickly as possible and not learn another query language again. We definitely wanted a cloud-hosted solution because we don't have infrastructure and DevOps resources internally. We're a small team. We're trying to make the most out of it. So I didn't want to waste my time in configuring infrastructure resources, especially in the early stages when you just want to get started and actually write some code and provide value to your users. What is great is it's all open source. There are Docker images for local development. So we definitely pulled those in, started Docker Compose, connected to MQTT, and got the data directly into our local systems. So you can experiment with it and experiment with queries and everything locally. And it was super easy to get data in there. The whole database in the beginning, if you start with it, you can start with implicit schemas. So the schema is generated on the fly. Whatever you throw at TDengine, they make sense of it and generate a schema for you in the database. And then eventually you can switch to explicit schemas and make your data more stable and move to migrations and all that. So those were all the arguments why we decided to try out TDengine, and we decided to stick with it. Where was I before? So this is a screenshot from one of our dashboards. It gives you an overview of the site. It shows a lot of important information, like what's the current wind speed on the site, what are the motor currents, off-target trackers to debug what's going on. If there's something not right, you will see that there. Obviously, there are field tech personnel and staff. They know exactly what to make out of these data points, and they know exactly where to start debugging issues. And we try to help them as much as possible with like color coding and reports and filtering to direct them to the issue as quickly as possible and give them all the tools they need to debug, because there's so much stuff going on with these sites, with a tracker. There's so much data coming in, so many things that can go wrong. So this is a great tool for everyone to quickly debug, see what's going on, and then decide if they need to send field staff out there to remove something from the tracker, for example, if the movement is blocked, or if it's something that we can solve with a software update. And then obviously we have the commands on the top right where you can manually override the tracking schedule depending on the conditions, what's currently happening. Like if they decide to mow the grass or clean up the site, there's a servicing mode for that. And then the trackers won't move in that period, for example. So again, time series data, it doesn't really have a primary ID or primary key. Everything is organized in TDengine by keys and values, which is going to take a while to wrap your head around how to really query and deal with this data effectively. At least it took me a while, but we decided to use keys matching our Postgres IDs. So we can actually match the time series data with our relational data and have, for example, a transparent GraphQL layer where you get the data from both databases, the relational database, like what the site meta information, the number of trackers, the number of zones, all that stuff, with all the static data, and at the same time in parallel pull in the time series data for every zone, for every site, for every tracker, and run all these queries in parallel, which is pretty cool, and deliver that as a GraphQL or REST response, completely transparent to the user. They don't know, obviously, where that data is coming from, and it's all combined on the API. That's pretty cool. One of the things I mentioned a few times now is aggregation. So one of the biggest features that you get with time series databases that you don't get that easily from MySQL, or if you don't use these time series management systems, is inbuilt aggregation functions. In TDengine, they're called stream queries. So you define a stream query that's essentially processing all the data that's coming in real time and puts it into these into these aggregation buckets. One feature that's pretty cool for us, for example, we can define time window streams where we are pre-define the time windows, like 5 minutes interval, 1 hour, 12 hours, just examples. And by having these predefined tables in Postgres, their views, they're processed a lot faster than if you query something. We can switch between those time windows in our graphs, and the data is all loaded almost instantly. So this is super fast in terms of user experience, and yeah, super helpful if you're dealing with this kind of data. And again, helps you to kind of zoom in and out of your time window and really inspect, like something went wrong an hour ago, so you're really deep into the milliseconds of every event, what's going on there, and then you can zoom out again and you see that one little point there, like, okay, something went wrong here. So that's really cool. All right, so what we learned, time series data, like if you're dealing with this kind of data, if you identify that you have data is coming in that has a timestamp and is not really that relational, it's just values that you need to aggregate or that you need to make sense of, these time series databases are a great choice. It helps you a lot with inbuilt functions to aggregate to some to use all these. Yeah, one thing that I want to mention, like clustering data. So there's partitioning features, for example, where you can partition your data into days and weeks. You can partition by site, by tracker, and all of that is built in. So you don't have to spend a lot of time in building this and coding this yourself. You get a lot of value out of using one of these systems. Obviously, for us, we use Fastify and OGS. It's awesome. Big fan. And for the interface, we started with GraphQL because in the beginning, there's a lot of data to deal with, and we didn't want to spend a lot of time defining the REST endpoints and documenting everything. So we just moved everything into GraphQL and decided the front end can pick whatever they want. But we're transitioning now back to kind of REST-y endpoints now that we know exactly what kind of data we need and what we're dealing with, writing specialized queries in combination with these stream queries and so on, just to make these calls more lightweight and more maintainable in the future, and reduce the complexity on the front ends to make everything a lot faster.
Cool, awesome. Thank you, Patrick. That was a very informative presentation. I'm sure everyone can get something useful out of it. So before we go into the Q&A session, just so everyone know, we just came up with a tutorial set for TDengine. It's really for you to, if you want to experience TDengine, you can try it out yourself. It's a hands-on tutorial, almost step-by-step tutorials for you to, you can register, you can sign up for the TDengine cloud, and you can follow the tutorials and finish these data ingestion. You can also do a lot of build some applications based on TDengine. It's going to be very engaging, very interesting. I encourage everyone to use the link to go to the page and give it a try. So if you want to learn time series database, or if you want to know more about TDengine, I think try it yourself is much better than hearing other people talking about it. Although Patrick did a very good job with today's presentation, I think it will be even better if you can try it out by yourself, hands-on. I think that's always the best way to learn a new tool, or to evaluate whether or not this is suitable for your application, for your organization. Okay, all right. Now let's we'll wait for a few seconds for people to ask their questions. But overall, Patrick, I want to just ask you, what is your experience so far? After you guys started using TDengine, what is your experience working with the team at TDengine, and also what about the tech support side?
That's a good point. So that was one of the winning arguments for TDengine. Obviously, joining the purchasing the cloud edition, we got great support. We started with a Discord channel, moved everything over to Slack. Get great responses from the development team if we have issues with queries, for example. There's always obviously limits to SQL in the time series functions, especially. So obviously you can read the docs and get into it, but eventually there are things that you don't understand, or that can just be done faster if you've worked with us for a while. So TDengine has helped us a lot with optimizing queries, for example, helping us if things aren't working. So that was really great. Thank you.
Awesome. Yeah, thanks. We do have a few questions coming in right now. First question is addressed to you, Patrick. Are you guys planning to add any prediction and alarm capabilities to the product anytime soon?
That's on the roadmap for us, definitely. We have a few ideas. Obviously, we'll also need some support from TDengine to make this work. Especially the alarm triggers and all that stuff. That's going to be a hopefully collaborative effort to make this work in our products.
Okay, perfect. And another question: how does the support model works in case of open source software for TDengine? As Jeff has answered in the chat window, so we do have a Discord channel. We encourage everyone to try out the open source version. If you have any questions, please join the Discord channel group, and we will always have someone there to answer your questions on there. And another question was regarding is TDengine in the Brazilian market? Yes, we are globally very popular. So we have over 50 countries. We have presence in over 50 countries, and we have, for our open source version, there are over 600,000 people already downloaded our open source version. So it's definitely has a huge presence in the Brazilian market as well. And another question, so someone was asking for the presentation for today's session. If you need a copy of today's slides, please send an email to the email address on the screen listed. So it's jfan@tdengine.com. I'll be more than glad to provide you a copy of today's slides. And everyone who registered will get also a recording of today's webinar, so it will be sent to you in a few days following today's live session. Another question I got from my side is if all time series databases are using similar compression algorithms, why TDengine has better compression performance? So we say besides the two-tier, like the two-stage compression that we do for all the data that's ingested, there's also a unique design. It's what we call one table per device. So since we're using a lot of delta of delta encoding for to compress the time series data, it means that we're not storing all the exact number. For example, if we're talking about voltage, if it's 22 volts, the first number is 220, the second is 221, the third is 219. So we only store the first metric, first number, and then the delta, which means what is the difference between the second one and the first one. So with that, if we store with our configuration is that for the same device, we'll create a separate table for you. And usually within the same device, the variation for the same metric is smaller compared to, let's say, you're putting two different devices in the same table. So with smaller variation, you get smaller delta, and that leads to even higher compression ratio compared to the other time series databases on the market. And that's why we were able to achieve an even better compression ratio compared to the other solutions. Let's just browse through the questions. And there was also a question asking about for Nevados operational data, do you guys have plan to use that to improve your hardware products in the future?
Yeah, we're already working on that. So obviously now that we have this data that we didn't have before, there's a lot of information in there that we can use, and hopefully, again, it takes time to make sense of all this data, but improving the hardware controls and everything is definitely on the roadmap as well.
Okay, perfect. Another question from one of the audience is that, is there a way to add data to the Nevados database, like an API, for example? Let's just stream that question.
No. So essentially, ingest all works through MQTT exclusively. So there's no way to get data in there outside of MQTT, and all of this is secured. So obviously data needs to be protected as well. For querying, we use the API. So all the queries run on the API and all the ingest is through MQTT.
Thank you. There's another question. What are the specific advantages of TDengine over the other common time series database platforms? I think our founder and CEO, Jeff, has been answering a lot of questions in the chat window, which is very helpful. And so, as you can probably see in the previous slides, compared to the other major time series databases, we do have a superior performance regarding the ingestion ratio, ingestion speed, the query speed, and also we consume less resources. So we're cheaper to use with higher performance. So we're a newer technology compared to some of these existing players on the market. And okay, I think there are some other questions still due to the time limit of today's session. We're at 45 minutes now. There are some other questions that will definitely follow up after today's event. Again, you will get a copy of the slides if you send us an email. We will also send you the recording for today's webinar, and you can watch it again or forward it to your colleagues. And for the questions that we have not answered, we'll follow up with you after the event. So thank you everyone for your participation. Thank you, Patrick, for a very interesting, very informative presentation. We really appreciate it. Thank you, everyone. Thank you. Have a nice day. See you guys later.
Have a good day.
Thank you. Bye.